Okay, class, a couple of things you need to know about this one. It says she's going up the mountain and then she's coming back down. The time of day is here, so you can see it's jumping in increments of 2 each time. On her distances on the first day, and we'll start with that one because that one's a little bit easier. Her distances are increasing incrementally. All right, now what I want you to see is that the distance is, well, the rate really is distance over time. And I think you already know that. You already know that based on just, I don't know, rate times time is equal to distance. So rate is equal to distance over time. So this is actually like a slope. This rate is a slope. And they've been reinforcing that idea to you already, so that's not new. But it's basically like delta D over delta T. Kind of like change in X over change in Y. All right? So let's do let's see what the change in distance is on our first day. Let's just use these first 2 increments, although we could use any of the increments because you can see they're jumping by 2 each time. So we can see that this is the final minus the initial. So 2 minus 0 is 2, okay? Now what's the change in time? How much has this jumped? How much has the time changed? Well, 2, okay? So our slope is 1, right? Okay, so now all we need to know is how to write the actual equation. Well, I know this may feel like a bit of a stretch to you, but you remember rate times time is equal to distance, okay? So technically what we have here is our y-intercept form. We have distance equals 1 times the time. So there's our first equation. It says graph those equations, which you're going to have to do on your own. So we have distance is equal to, I'm going to put a 1 in here so you understand that we've already identified the rate going up the mountain on the first day, okay? Now we need to do the one that's a little bit harder, okay? So again, we need to find the rate. I'll actually change the color here so we can keep this straight. And again, we need to find the rate, okay? But this time we're going to say the rate is equal to the change in distance. But this time, the distance from 5.75 to 8, okay, remember it's final to initial, so it's 5.75 minus 8, okay? And then the change in time is still 2, right? Okay, so this is 2, all right? Now, I realized something when I was looking at this. I realized that these increments are 2.25, 2.25, and all of a sudden it goes down. Or maybe this one is, but all of a sudden this one's increment isn't consistent. So that's actually kind of a breakdown in the data. I'm sure it's accurate data, but that means that our graph would technically, our line of best fit may not be the actual line of best fit. But I don't care. For this one, we're going to use this as our data. Okay, so we're saying the change in distance coming down the mountain is going to consistently be 2.25, negative 2.25 every 2 hours. Okay, so our rate then, if you change that to a decimal, is equal to negative, rate equals negative 1.1, whoops, I've got an extra decimal there, negative 1.125. All right, so now our second equation then we can say is distance equals negative 1.125 t. Well, there's our 2 equations. Now, I don't care if you just graph these in your graphing calculator. In fact, I would probably recommend that just because there's enough other things going on that you don't need to do that yet, okay? So graph these equations, use your graphing calculator, no problem. Is there a point on the path at which Irma arrives at the same time of day on both days? So listen, guys, what you need to be looking for is the place where those lines intersect, okay? So if you once you get these 2 graphs into your graphing calculator, there's going to be a specific place where those intersect, okay? And that's what this question right here is asking. You can use the calc feature and then the intersect, remember? So I think you should be able to manage that just fine. But how can you interpret it? Because it's going to spit out X and Y values at you, not D and T values, okay? So what you're going to have to recognize is that the T is like the X value, okay? And the Y is like the D value. So that's how what you're going to use to interpret that. And I'm going to let you guys fight with that. I will give you a hint that the distance and in miles and the time in ours, actually the numbers are very close, if not the same numbers, oddly enough. So hopefully